Welcome to Azad Bioacademy. Today's lecture topic is Gprotein and Gprotein coupled receptor. Okay, so this is Gprotein and Gprotein coupled receptor. Okay, so firstly we have to know what is Gprotein. Okay, so here is the two part, one is G, another one is protein. So firstly, you know the protein is the polymer of amino acid. So one type of protein, which is called G protein. Why it is called G protein? So what type of protein it is? So this is one type of protein complex that is made up of three subunits, that is alpha, beta and gamma. Alpha, beta, and gamma has three different types of subunit which will assemble and form a protein, that is G protein. That's why it is called heterotrimer protein. Heterotrimer protein. That means heterotrimer. That means one unit of alpha, one unit of beta, another one is unit of gamma. Alpha is different protein subunit, beta is different protein subunit, and gamma is different protein subunit. That is by hetero, and 1, 2, 3, that is the trimer. So G protein is one type of heterotrimer protein, which is associated with G. What is G? Why G comes here? So G means guanosine. That means initially the heterotrimer protein is associated with a GDP, that is guanosine diphosphate. So from that part, the nucleotide guanosine diphosphate, so the guanine turn into bind with the sugar and phosphate, and that will turn into the nucleotide. Okay, the first, the base, nitrogenous base is guanine. So from that, the G comes. Okay, so G for guanosine, and initially the guanosine diphosphate is attached with a heterotrimer protein. So in overall assembling form is G protein. Okay, so G for guanine and the protein, and protein is made up of three different subunits. Okay, so just I will try to draw a G protein by different color, then that will be very easy to make a sense. That is, if you think this is the one protein subunit, this one is another protein subunit, okay, another protein subunit, and here is another protein subunit. Okay, so three protein subunits are attached each other and form a trimer. Okay, so this different protein 1 to 3, so heterotrimer. Okay, and here within alpha, this is alpha subunit, this is the beta subunit, and this is the gamma subunit. Okay, and initially with the alpha, one additional things is attached here with, this is the GDP. Okay, that's why this protein is called G protein. Okay, so G from GDP, and this is the protein. And protein 1, 2, 3 subunit, that is the hetero, and 1, 2, 3, so trimer, so heterotrimer protein. So G protein is one type of heterotrimer protein, which is attached initially in inactive form with GDP. Okay, so this G protein is considered as a switch protein within the cell. Okay, when it will activate, then as like when you will press the switch, it will just activate your fan or your light like that. So when Gprotein will activate, it will show different function or signaling in your signaling pathway. That means downstream different signaling pathway. So how it will be switched on, how it will just become active. Okay, that is the one of the uh, one of the major questions. So now we have to consider another thing, a receptor, because this protein is present inside the cell and something will directly activate it. Most of the things in your body, in your cell, most of the drugs, ligands are not allowed into the cell. Some particular ligand can enter into your cell that can show its function in your cytoplasm or nucleus. But most of the ligands are not allowed. Okay, so how it will work? That is the question. So when I will consider it, then you have to consider the receptor on which ligand will bind. Okay, so then next topic would be the G protein coupled receptor. Okay, that G protein will be coupled with the receptor. That is the G protein coupled receptor. So here, just come. This is the G protein. Already I have drawn the figure. So I will just attach it. Suppose if you think this is your cell membrane, okay, and this is one type of receptor, okay, and this receptor is attached with the protein, G protein. So G protein is attached with the receptor. So what would be the name of the receptor? Very simple, that is the G protein coupled receptor, because this G protein is coupled with a receptor. So this receptor name is G protein coupled receptor. That's it. Okay. Some drugs will activate that G protein, but that drug will not allow into the cell. So how it will work? So firstly, it will just bind like that. Okay, so if you think this is a ligand that will bind with the binding site of the receptor. Just I am drawing here the receptor structure because the G protein coupled receptor is like a serpentine, that is like a snake. So because it is crossed 7 times within the membrane, so you can the G protein receptor can be called serpentine receptor. You can call 7 cross or 7 pass receptor, or you can say it is the metabotrophic receptor. Okay, because of that, I have drawn the figure like that. Otherwise, simply it would be drawn like that. This is the membrane and this is the receptor, and it will the binding site. This is the ligand like that. Okay, so when ligand bind with the receptor structure, the receptor basically tertiary or sometimes quaternary structure. So tertiary structure of the protein will just stretch to capture the ligand. That means when ligand bind with the receptor conformation will change. When receptor conformation will change, and this receptor is attached with the protein. Okay, so signal will just come into the protein, and the protein will be activated because that protein is directly connected or attached with the receptor. That receptor is the protein coupled receptor. Okay, so when ligand will bind with the receptor, conformational change will occur, and that will just transmit the signal to the protein, and that protein will be activated. What protein? That is the G protein. And G protein is the sum of alpha, beta, and gamma. So what will happen? So alpha is the largest part of the G protein, that is alpha, and second largest is beta, and the smallest one is gamma. Okay, so alpha is directly attached to the receptor, and beta and gamma is very much close to each other and um, uh, very much closely attached, and thus beta part is attached with the alpha. Okay, so this is the beta part, and which is attached with the alpha. So alpha is attached with the receptor, and beta and gamma, they are separately attached to each other, and beta is attached with alpha. Okay, so when the alpha will be activated, that activated G protein will also activate the beta gamma. Okay, when it will be activated, what will happen? That is the another question. So after binding to the ligand, the conformation will change and the stretching will occur and G protein will be activated. When G protein will be activated, that GDP will just come out from here. Okay, GDP will just out, GDP out, and here from within your cell, the GDP will just come out from here or detach from here. Okay, and another things, that is GTP will be replaced, not converted. GDP by addition of phosphate, it will turn into GTP. It is not. What will happen? It will just exchange, replaced. That means GDP will detach from the alpha part and GTP will attach. Okay. So finally, that G protein will be activated. Okay, that means very sequential way. When ligand will bind with the receptor conformation will change and it will just activate the G protein. How it will be activated? Because it will be activated by the exchange of GDP to the GTP. Okay, when GTP will attach, then what will happen? It will be separated. How? That part, like, that is the here GTP is attached, okay, and here that means this is alpha and this is beta gamma. That will be separated. Beta gamma complex will be separated, and that is also active, and this one is also active. So this is the active G protein alpha, and this is active G protein beta gamma. Okay, it can show the function in your effector organelle or signaling pathway, or this can also active. Okay, so mostly prominently alpha is more functioning than beta gamma. Both can give its function. And how it will give its function, I will give some example. Okay, so before that, what will happen? Suppose if you think this activated G protein will show its function, and then what will happen? So I will just cover it and then I will go for example. Okay. So suppose this alpha G protein is just activated some substances and just finished its function. Then what will happen? Its GT page activity, GT page capacity, that will hydrolyze the GTP. Okay, and what will happen? GTP will turn into GDP. Okay, like that. GTP is attached with the alpha, and GTP will be hydrolyzed into the GDP, and that, like that. After I will say after function. This GTP phosphate turn into GDP, and that GTP will attached here. Okay, like initial the inactive G protein. So this is the GT page capacity or activity of the alpha, and that will hydrolyze the GTP into GDP, and this is inactive G protein alpha, and that will again attached with the beta gamma, and again it will form alpha beta gamma complex, that is heterotrimer, and it will attach again into the receptor, and just wait for the next activity. Okay, so I will just sum up. After activation of the receptor, that means ligand bind with the receptor conformational change will occur, and that will make sense to change the G protein activation. When the G protein will be activated, that means it will just GDP will exchange by GTP, and the G protein will be activated. Alpha part will be separated from the beta gamma complex. Okay, alpha G protein will be active G protein, and beta gamma also active, and that part will show its function in your signaling pathway or in effector organ or even directly your ion channel. Okay, and after that, the alpha G protein has its own GT phase activity that will hydrolyze its attached GTP into the GDP, and when GTP will turn into GDP, and it is also associated with the alpha, and then it will again reassemble with the beta gamma complex, and finally again it will form a alpha beta complex heterotrimer and wait for the next one. Okay, I will just here add something, that is beta gamma always in attached with each other, that is complex before and after, and alpha just after activation it will be separated, and after finishing its work again it will assemble with the beta gamma complex. Okay, so now come to the next part, that is example in the G protein. Okay, so already in my vasodilation or vasoconstriction part, I have given some example details like with G protein, but here G protein I discussed deeply. So I will just very quickly I will try to give an example. Okay, so suppose this one is cell membrane. Suppose if you think this cell is of blood vessel. Okay, and here is one receptor, that is alpha 1, and this is G protein couple receptor GDP alpha 1. Okay, and here adrenaline will bind. Adrenaline will bind. Then what will happen? G protein will be activated. This G protein, if you think this is alpha G protein, will be activated. Here I just missed out one part of the discussion, that is types of G protein. So that is unfortunately I just forgot. So now here I will add the types of G protein. Types of G protein has several types, but mainly if you just know the 3 types of G protein, then you will cover most of the physiological function related to G protein. Okay, so that G protein, you know, they're composed of alpha, beta, gamma, heterotrimer, but it has 3 types. It had several types, but mainly we will consider three. One is Gprotein I, second one is Gprotein S, and third one is Gprotein Q. Okay, that means that Gprotein has inhibitory function, so that is the Gprotein I. Gprotein has stimulatory function, so that is the GS, and Gprotein has a particular function on the phospholipase C associated IP3 and DAG pathway, that is the GQ. So why it is called Q? Actually, the Q is a symbolic form to just indicate a particular protein, that is Gprotein, but actually somewhere it is called quaternary, but actually is the why it is called GQ is still it is not clear. But in some places I just find out this quaternary, but actually it's not well established. Okay, so that's GQ. So three types of Gprotein. So now come to the point. This Gprotein coupled receptor alpha 1 is a type of GQ. So if you think this is the alpha part, here GTP is attached because it is active. That's active GQ will just activate the uh, protein enzyme, which is phospholipase C beta, which is present in your cell membrane, and there phospholipid are there, and it will make IP3 and DAG. Okay, that is the second messenger, come from phospholipid breakdown and inositol. Then IP3 is the second messenger, it will activate the endoplasmic reticulum, and that after binding the IP3 receptor, and it will release the calcium. Okay, that calcium will bind with the calmodulin. That calcium calmodulin complex will activate the myosin light chain kinase. Okay, and when myosin light chain kinase will activated, then it will just make the myosin to the phosphorylated myosin. That means phosphate will attach. Phosphorylated myosin will be able to bind with the actin. That means it will form actin-myosin complex. And when actin-myosin complex cross bridge will form, then contraction will occur. Okay, so if you think this is the blood vessel, so smooth muscle, this is the contraction. That means when adrenaline binds with the alpha-1 receptor on the blood vessel, then it will cause vasoconstriction. So this is the example of Gprotein and Gprotein coupled receptor. Okay, so here DAG can activate G can activate the PKC, and that will help to gene expression. Okay, so this is all about the Gprotein. So I will just very quickly I will try to sum up. Gprotein means one type of switch protein inside the cell, that is G protein because it is the heterotrimer protein. This is alpha, beta, gamma subunit, and initially it is inactive because initially GDP is attached with it, and that G protein is attached with a particular receptor, that is Gprotein coupled receptor. When ligand or any drug bind with the receptor, then the receptor conformational change will occur and Gprotein will be activated, and GDP will exchange by GTP, and finally Gprotein will be active. That active Gprotein will be separated alpha and beta gamma. So alpha will work in separate way, and beta gamma complex can also be active and can show its function. So I will already cover the way of working as a Gprotein. And finally, after completion of the work, the alpha part has a GTPase activity, and that will hydrolyze itself connected GTP and convert into GDP. And finally, again it will reassemble with the beta gamma complex and form the alpha beta gamma Gprotein is associated with GDP, that is inactive form. So this is all about Gprotein. Thank you very much.